start about chapter 5. The title will be on the second law of thermodynamics. In this chapter, we are going to see what is a second law of thermodynamics. It stated that a process could not happen unless it satisfied first and second laws of thermodynamics. In the first law that we have studied, it is explaining about the characteristics of energy balance, which defines the quantity of the energy. In this second law, it will defines on the direction which the process can take place. So it is also explaining on the quality of energy. Okay, for example, we already know that if in the hot coffee which we put in the room temperature, the heat from the hot coffee can be transferred to the ambient or the room temperature. So for example, if the room temperature is 24 degrees Celsius and this hot coffee is about 60 degrees Celsius, so heat can transfer outside the hot coffee. But if you want to take the heat from room temperature and transfer it to the hot coffee, in second law said it could not happen. It is impossible to happen. So a cup of hot coffee does not get hotter in a cooler room. Okay, another thing that we can say about how the heat is transferring. If we have a system like this, where this shaft can be rotated, transferring. If you transfer heat, the pedal wheel will not cause it to rotate. So this shaft is actually can take the load up and down if it is rotating. So basically or logically, if we transfer heat to this system, this system will not make any work. It won't make any work. The heat won't rotate the shaft. So in the second law, it's saying that the heat will not make any work, and you need a device to change heat to work. So this process can occur even though they are not violation. Then they are not in violation of the first law. So the process can happen. So what the second law of thermodynamics is saying, that process occurred in a certain direction only, not in just any direction. So it is a one-way process. This is true for water falls from downhill. The water will go from higher hill, higher land to a sea level or the lower level. Also, gas always expand from high pressure to low pressure. So if we have a balloon here, we will hit the balloon. So this the heat from the gas burner will be expanding inside the balloon, which is the lower pressure than the gas burner. So by this, when the balloon get hotter, it will go up. Okay, another example in the normal life, if we have a thermo or heater where at the heater will be about 80 degrees Celsius to maybe sort of that. So the heater, the electricity will get this uh, heater, and the heat from the heater will be transformed to the room, where usually in winter the room temperature will be about from 8 to 10 degrees Celsius. So the heat will go from high temperature to the lower temperature. Okay, so this first law gives us no information about direction which the process occurred. It just tells us that the energy must be balanced. So when a 24 degrees Celsius and 60 degrees Celsius system, sooner or later the energy will be balanced, so they will become uh, uh, they will become equal temperature. For example, if the coffee in 60 degrees Celsius and the room temperature 24, usually the coffee will become 24 degrees Celsius. So for the second law, it tells us about the direction of the process. You see just now, from high temperature going to the low temperature, and it is not opposite. It will not be reverse. So major use of second law is the second law may be used to identify direction of process. The second law also asserts that the energy has quality as well as quantity. The first law is concerned about the quantity of the energy and the transformation of energy from one form to another with no regard of its quality. But in the second law, it provides necessary means to determine the quality as well as the degree of degradation of energy during the process. So this second law of thermodynamics is also used to determining the theoretical limit or the efficiency of the performance, and commonly used for engineering system and such as heat engine and refrigerator. Usually we will see the efficiency as well as predicting the degree of completion of the chemical reaction. Okay, another thing that you have to know is the thermal energy reservoir. As we know that before this, a system that remains constant temperature even though heat is added or removed from the system. And atmosphere, lakes, furnace, saturated acre, etc. The system usually will be in constant temperature. They'll try to remain in constant temperature. So if you want to have a system that can transfer heat to work or convert heat to work, usually you should have two two thermal two reservoir, sorry. A reservoir supplying the heat will cause as source, and a reservoir receiving the heat we will call as sink. So thermal energy is source, they're giving heat, and remaining heat will be receiving by the sink or be absorbed by the sink. So a source supply energy in the form of heat, and the sink will absorb it. Okay, for example, work always convert directly and completely to heat, but not reverse. This is one example why we say this. For example, if we have a shaft and a rotor or blade inside the water, if we give a work to the shaft will keep on rotating. So by rotating it, the water inside will get some energy and some heat from the rotating shaft. So if so, this means to say that it will produce heat from the work. It will produce heat, and this heat can go outside from the system or this container. But if you don't have any work on the shaft and the blade is not moving, if you put or you transfer heat inside the water here or the container, this heat alone will not move the shaft. So if it is not moving the shaft, it means that no work is produced. So work and heat are not interchangeable form of energy, but there is a device that can convert heat to work, and we call it as heat engine. So we need a device to convert heat to work.